So, hi everyone. Today we are going to talk about Google Drive. Uh, in the previous videos, we have already talked about big applications, building them from scratch, system designing them. So this one is quite different because in this we are going to tackle a lot of storage thing because Google Drive is famous for and is in a need for uh, people who need storage, right? So as usual, we are going to start with the same way. We are going to ask some clarifying question to ourselves that what we are building, and then we are going to move forward, right? So let's start. So when it comes to Google Drive, what comes into your mind? Like the first thing is storage. The first thing is storage because you can store a lot of things in Google Drive, backed by Google, prominent place for storing your stuff, right? So for this particular video, we are just going to build the core product of Google Drive, which is the storage product. So in other words, we can create folders and upload files. So the Google Drive is going to store them in cloud, right? So we refer to these folders and files here as entities, right? So yep. So there are a lot of features in Google Drive. You have a lot of features like you can share company drives, personal drives, permissions on entities, starred files, recently accessed files. So for this particular video, we are going to narrow things down. You can going to narrow things down, right? So we can forget about shared company drives. We can think of a personal Google Drive. Users can store entities, and that's all we need to take care of. Ignore any feature that isn't the core to the storage aspect of Google Drive. Ignore things like files, recently accessed files. We can ignore these things. So we are primarily considered the storing entities. So once these entities have been stored, there can be CRUD operations on them. We can create, rename, update, and delete them. So yeah, we are going to definitely look at them. And for this video, one more thing we need to look at. We are primarily designing this for the web part. The web part, right? Uh, since we are not dealing with share entities, we handle multiple users in a single folder at the same time, or we can assume that this will never happen. Well, we are not designing the sharing feature, so let's still handle what would happen if multiple clients were in a single folder at the same time. So let's handle that case, right? So we are now, let's look at how many people are we building this for. Uh, Actually, there are a lot of users of Google Drive. So for this video, we are going to assume we are going to build this for 1 billion users, right? And for every user, we have, let's say, take an average 15 GB storage, 15 GB storage, right? So, yep. So from this point, we can actually say we need to build this for 15,000 petabytes. 15,000 petabytes. This is the storage that we will need in total, and it needs to be highly available, right? So we have talked about nines. You remember we talked about nines, that how many nines can be for the latency and availability. So for availability, let's take 4 nines, 4 to 5 nines, let's say. So 5 nines will be 99.9995 nines of time it is available throughout an year. So it is going to be a very good thing if this happens, and no data should be lost. Data should be preserved. Data can't be lost because that is the core functionality. So now we know that there are two entities. One is files. Another is folders. So and the operations like create folders, upload and download files, and rename files are happening once they are stored. So we have the CRUD operations here, right? CRUD operations, right? So now we are good to go. So let's come up with a plan as usual. This is the first thing that we usually do. Cool. So here comes the plan. So when it comes to things for files, what can we do with them? So for files, actually we can upload, we can delete, rename, we can move, Then we can download, and then we can edit. So these are the things that we do, right? Now, when it comes to folders, let's take a mark here. Folders. Let's directly mark them. What can be done here also. So let me change the color. Yep. So for folders, we can even do upload, right? Actually, we can't do upload. Sorry, we can't do upload. We can create folder, right? We can create, then we can delete, create, delete, then we can rename. Then we can get the folder, and then we can move the folder. These are the 5 operations that we can do in a folder. So now we know all the things that we can do. Yes. So now it comes to storage solutions, right? So storage solutions. So it's pretty important, right? Storage. So when it comes to file contents, for file contents, the file content, we have bytes with no particular structure. And for entity, the metadata for each entity, this might include field like. So this was file structure. Now we have entity. So we have metadata, right? So inside metadata, we have fields like entity ID, then we have owner ID, then we have last modified, then we have let's say entity name, and then type. These are the things that we have. So we are good to go, right? So let's start with storing entity information only. Storing entity information. Cool. So let's look at this. Yeah. So to store entity information, we can use key value store, because key value store is the best thing that can happen here, because it will map everything accordingly that we need. Since we need highly available and data application to happen, we can use for key value store something like a third party service that can be, let's say, Zookeeper, or we can even use Google Cloud Spanner, GC Spanner, that is called GC Spanner, right? So we can use 2 of these entities. That gives us both of these guarantee as well as consistency. So since we are dealing with billions of GBs of data, there is what we talked about. Like we talked about 15,000 petabyte, right? 15,000 petabyte. So we will need to share this data across multiple clusters of this key value store. So sharding on entity ID means that we'll lose the ability to perform batch operation, right? So instead we can shard this. On the basis of owner ID, because this is the best way to we can edit the metadata of multiple entities automatically with a single transaction. So log of the entities belongs to the same user. So sharding this whole 15,000 petabyte on the basis of the owner ID is the best possible case here, right? So given the traffic of the website needs to be served, we have a layer of proxies for entity information load balancing as a hash of owner ID. So owner ID is the best thing on which we can shard the whole data here. Cool. I think we are done with this storing entity information. So we can move to the next part. Let me just change once again. Yes. So the next part is storing file data. Storing file data. So when dealing with potentially very large uploads and data storage, it's often advantage to split up data into blobs, right? To piece back together to form the original data. We have already talked about this. So when uploading a file, the request will be load balanced across multiple servers. So this we will call it as blob. We already know that this whole data will be called blob, and this will be known as blob splitter, because we're splitting this whole data. So I'll just show you guys how this whole process is going to work like. So think like this: you uploaded a file here. This was the file, you uploaded it right on the load balancer. Obviously you're going to submit it to through some API. Now this is going to split it, right? 1, 2, 3. It has split itself into 3, right? So these are the blob splitter, right? Blob splitter. Now this whole will be load balanced to blob hash. So here you go, blob hash. Cool. So once this is done, this can be given to proxies, right? Proxies. So let's say there are a number of proxies: 1, 2, 3, 4, 5, 6, 7, right? These are the proxies, and so proxies will be giving that to the blob storage, right? The main blob storage where everything is happening. So there are replicas also: 1, 2, 3. So it is giving to them. So at last we have all the pieces together, the blob storage. So yes, then we can give it to replica, whatever replica we are storing it in. 1, 2, 3, right? So we are good to go. So we have uploaded it, load balanced it, gave it to blob splitter, then we load balanced it on the hash, blob hash, then we gave it to proxies, and then proxies gave it to blob storage, and then to the replication. So storing these blobs in some global blob storage is the best solution that we have here. So let's say we can go with Google Cloud Storage, GCS, or Amazon S3, right? Obviously this is Google Drive, so they will be going with Google Cloud Storage, right? So in order to avoid having multiple identical blobs stored in our blob storage, we will name the blobs after the hash of their content. So this technique is called content addressable storage. So by using it, we essentially make all blobs immutable in storage, right? Yes. So we are good to go. Now once we have done with this, we can actually move to the metadata information, right? The metadata. So the file information structure would look something like this, I think. For every file, let's say this is the file information. So inside this, what all things we will have? Let's say we will have the blob. Just change the dot size. Yes. So this is the blob. Now inside this there can be hash ID. Then we can have content ID, right? So now we know that the blob is going to be like this. Then we will have an ID. This ID can be some particular number, some unique, like 3, 2, 6, 4, something like that, a particular number that is unique, right? And we need to tell if it is a folder or not. So folder is equals to false here because it's not a folder. And then we can have something like name of the file, right? We can have name, whatever the name is. Then we can have owner ID, right, to make sure that we know that who is the owner of this. So owner ID. And then we can have the parent, that which parent it belongs to, like which folder, like something like that it belongs to, right? So this is the file information, right? Then we can move to the folder information. Just change the size back. Here we go. Cool. So now we have to get into the folder information. So how is folder information going to look like? So it will have children ID. Like above we had parent, so in this we will have children. So let's say there is this file 1, then we have file 2, then we have some ID, then we have to check, is it a folder? Folder equals to true. Then we have the name, then we have the name, then we have the owner id, then we have parent id, right? We have parent id. So yeah, we are good to go. We already have defined the structure of this entity, so we are done with the metadata, right? Now comes a very important part, that comes to garbage collection, right? We haven't talked about this in any of our videos till now, so listen to this very carefully. uh, Garbage collection, garbage collection, right? So any change to an existing file will create a whole new blob and derefer the old one. So furthermore, anyone can delete file which also dereference from the file's blobs. So we can have a garbage collection service that watches the entity information key value store, because there's a very huge chance. Suppose this is a key value store and this is the blob and this is some file, these are the exact information inside this particular file was deleted. So at that point, the key value store uh, and the entity information key value store keeps the count of the number of times every blob is referenced by files. These counts can be stored in an SQL table, right? For making sure that suppose there is this file name 1 and it is common in all of them. So whenever this is going to be stored, this will be decoupled, right? Because suppose it has a value of, or let's say 8 people are using it, right? And 1 is deleted, so this will reduce to 7 in the hash map. So reference counts will be updated whenever files are uploaded and deleted. So when the reference count is 0, it can be, suppose this becomes 0, it can be permanently removed, right? It can be removed. So yes, this is the method for garbage collection. So I think we are good to go. Now we can come to the last part, I think, that is the CRUD operations, right? So that is the CRUD operations. CRUD operations. So what we have inside CRUD? We have create folder. So simple, since folders don't have a blob storage component, creating just involves storing some metadata, right? Let's say 2 KBs, something like that. Then we have, let's say, what is next? Upload file, right? Let's say upload file. So it takes 2 steps. The first step is to store the blobs, and that make up the file in blob storage. Then make the file information object, store the blob content hashes inside its blob field, right? So yes, this was the first, this is the second. So yes, we are good to go. Then we have the third line, last operation, I think, download file. So it fetches the file's metadata from our key value stores given the file's ID. Then it can be used to combine the blobs of the data, right? So yes, that it's very simple, right? So it combines the multiple blobs in which it was stored, and it combines and give it us back, right? So yeah, we have done with the whole overall architecture of the Google Drive storage. Now let's design the system diagram. So when it comes to blob storage and everything, we will need to define the key value pair and everything. So let me just give you an overview how we are going to do this. So suppose there are a lot of blob storages, right? So we will have a very big storage diagram here, right? So inside this we are going to have a data replication tool inside which everything is going to happen. So my bad, yep. So inside this we are going to do everything, right? So this is the data replication where everything is up to date, right? Data replication. So this has multiple blob storages, right? Let's say you have one here, then you have you have here, then you have one here, then you have one here. Similarly, you have multiple blob storages here. I will just draw a few more and let it go. Cool. These are all the blob storages, right? And we already talked about the garbage collector. So it is going to be a very important thing. So this is the garbage collector. It is going to get connected to both of them, and then it is connected to, it is the garbage collector, garbage, and this is also a garbage collector, so it is going to be synchronous with this collector, right? So we have the key value store here also. We have a key value store. We have some key value store which is going to mark everything, because it's going to be get connected by garbage collector itself, right? So we have the key value store here, and the garbage collector, and the like data replication and blob storages here. So let's say all the operations happen here, right? Okay, my bad, once again. Yeah, so all the operations happen here. Let's say one operation is this, one operation is this, one operation is this, one operation is this. Let's define all of them. What was the first operation? It was upload, then it was delete. Okay, what is happening today? Yeah. Then you have download, then you have simply rename, right? So let's say for upload, we go first, it goes to load balancer, it gets into blob splitter, and then it goes to some proxies, right? And then these proxy take it to the blob storage, right? There are multiple proxies, so the blob splitter takes it to the number of blob storages here, right? So yeah, and then suppose similar things happen here. Suppose you are deleting something, or you are uploading or renaming. There is this load balancer here specifically for that. You have proxies here, that is the servers, proxy servers here, and then they are going to go to the key value store to update this, right? The key value store, they will go there. And suppose this is happening in one region. Let's say this is happening in India. Suppose there is this US client also there, USA. So same things are going to happen here, same as this. So yes, this is how the whole system design architecture of this will look like. So yeah, that was an overview of how Google Drive system design architecture will look like. So in the next video, we can actually talk about API things, how to design them, and how to make sure that they are understandable for us when we are designing them. So yeah, thank you and have a nice day.